Hello students, welcome to EPG Pathshala. I'm Dr. Hemraj Verma and I'm from DIT University Dehradun and I'm working as an associate professor in Department of Management Studies there. Today we are going to talk on module Introduction to Quantitative Techniques under the paper Quantitative Techniques for Management Decisions. After completing this module, the students will be able to understand the meaning of quantitative techniques, decision making basics, the relevance of quantitative techniques in business decision making, the classification of quantitative techniques, and various quantitative tools which are available for business decision making. Quantitative techniques can be defined as collection of mathematical and statistical tools that are used to provide powerful means of analysis using quantitative data for effective decision making in business. These techniques involve systematic and scientific methods of solving complex problems for taking effective business decisions. Quantitative techniques involve the use of numbers, symbols, mathematical expressions, and other elements of quantities and serve as a supplement to the judgment, intuition of the decision makers. These tools help business in optimum utilization of limited resources. Decision making basics. Decision making pervades all aspects of business. The word decide has been derived from Latin prefix "de" and the word "cedo", meaning "of" and "to cut" respectively. This led to the origin of the word decido or deciduous, referring to those plants, the leaves of which fall in the autumn. But that is the only one meaning of it. The other word derived from it is decide, that means take the plunge, suggesting the meaning of which making a wrong decision provokes the fear of falling. The decision making process. Decision making is a systematic process involving several steps, such as identifying the problem or the issue, identifying decision criteria, allocating weights to decision criteria, generating alternatives, evaluating and choosing an alternative, implementing the decision alternative, and finally, evaluating if the decision alternative was effective or not. For example, if an organization is deciding to buy laptops for its 500 employees, then it needs to first find out why these laptops are needed. What kind of configuration is needed in those laptops? The price, the quality, and the service warranties that different vendors will be charging. They also need to evaluate a set of vendors and then take a decision to order from a vendor. Uh, Decision making traditionally has been done largely on intuition or judgment of the decision maker. Now let's understand what exactly is intuition. So when a manager makes a decision based on his experience, feelings, or accumulated judgment, we may say that he or she is taking decision based on his intuition. Researchers have identified five different aspects of intuition, and they are experience based decisions, affect initiated decisions, which means decisions based on feelings or emotions, then cognitive based decisions, which are actually based on the skills and the knowledge of the decision maker, subconscious mental processing, and lastly value or ethics based decisions. Second aspect of decision is a type of decisions. So decision can broadly be classified into structured and programmed decisions or unstructured and non-programmed decisions. When problems are routine in nature, that is, they are simple and straightforward, we call them structured and programmed decisions, and we solve them by creating rules, procedures, and policies in the organizations. But if the problem is unique and complex, then we need to think out of box and we take decisions which are called as unstructured and non-programmed decisions. Other aspect is the conditions under which the decision making is done. So there are three conditions in which decisions can be made. One is decision making under certainty, decision making under risk, and decision making under uncertainty. So under conditions of certainty, a manager makes most accurate decisions as is aware of outcome of every actions beforehand. This is one of the most desirable and ideal situations, but in real life, we don't find these kind of situations quite often. Exactly opposite to it would be decision making under conditions of uncertainty, where a manager is not at all aware of all possible outcomes of his choice of alternatives. It's not even in a position to make some probable guess. So here the alternatives are chosen by a manager's intuition, judgment, hunch, or his psychological orientation. The third kind of conditions in decision making could be decision making under the assumption of risk, in which decision maker is able to estimate the likelihood of certain outcomes. Under risk, manager utilizes historical data from the secondary sources or from his personal experiences and assign probabilities to different alternatives. Other concept in decision making is whether the decision is rational or not rational. So what exactly is a rational decision? In a rational decision, when a person makes logical and consistent choices so as to maximize the value, we call it rational decision. But again, it may not be possible to take rational decision always, and that we can see with the help of one of the example. The decision of HP, Hewlett Packard company, for acquiring Compaq was a perfect example of a poor decision making on part of then CEO Carly Fiorina, who eventually lost her job as the company did no research to discover that the customer perceived Compaq products as inferior to that of HP, whereas HP people thought it other way around. So because the information was not there, so they took this bad decision. So it may not be practically possible to make rational decision always, because there is always a lack of information. So a more realistic approach to make decision is the concept of bounded rationality. As per this concept, managers make decisions rationally but are limited or bounded by their ability to process information. It is not possible for managers to evaluate all information on all alternatives, and therefore managers take satisficing decisions rather than a decision that will maximize his or her gain. That is, they accept solutions that are just good enough. Classification of quantitative techniques. Broadly, quantitative techniques can be classified into two categories. One, mathematical techniques. Second, statistical techniques. Mathematical techniques are those techniques that process quantitative data using mathematical principles to solve management problems, whereas statistical techniques use various statistical tools for better decision making. There is a whole range of mathematical quantitative techniques, which are algebra, set theory, permutation and combinations, matrix algebra, determinants, differentiation, integration, differential equations. And then there are programming techniques as well within mathematical techniques. For example, linear programming, assignment and transportation models, dynamic programming, inventory control, game theory, queuing theory, replacement models, simulations, decision theory, network programming, sequencing, quadratic programming, and there are many more. Second category of quantitative techniques fall into statistical techniques, and some of the statistical concepts and techniques that are used for business decision making are as follow. Basics of statistics, data classification, tabulation and presentation, measures of central tendency, measures of dispersion, probability and probability distributions, sampling and sampling distributions, estimation theory, hypothesis testing and decision making, analysis of variance, which is also called as ANOVA, correlation and regression analysis, forecasting using time series analysis, fundamentals of decision theory. Now it's time to look at the scope of the current paper, that what exactly will be covered in this course. As we have said before, that quantitative techniques can be of two types, mathematical quantitative techniques and statistical quantitative techniques. This current paper will only cover topics related to statistical quantitative techniques. In this course, we'll be covering statistical part of quantitative techniques, and we'll be covering following concepts and techniques of statistics. So basics of statistics, data classification, tabulation and presentation, measures of central tendency, measures of dispersion, probability and probability distribution, sampling and sampler distribution, estimation theory, hypothesis testing and decision making, ANOVA, correlation regression analysis, time series analysis and decision theory. So as we have said that this course is going to cover only statistical quantitative techniques. So as a part of that, it is time to look at some of the few concepts and techniques which will be covered in the coming modules of this paper. So beginning with basics of business statistics. So how we can understand statistics is that it's a science that deals with collection, analysis, interpretation and presentation of numerical data. That is as per the Webster's third new international dictionary. Broadly, statistics can be classified as descriptive and inferential statistics, whereas descriptive statistics deals with gathering data of a group to describe or reach conclusions about the same group. The statistics of this kind of is called as descriptive statistics. An example can be taken if an instructor gathers information about marks scored by students in his class and he summarizes the information to reach to conclusions about the class, then it will be an example of descriptive statistics. On the other hand, inferential statistics is that kind of statistics when a manager or researcher collects data from a sample and uses the sample statistic to reach to conclusion about the population characteristics. We term it as inferential statistics. The data gathered from sample are used to infer something about a larger group. Second concept which will be covered in the coming modules is data classification, tabulation and presentation, which you'll learn in detail there, but here I'm giving you the brief view. Normally raw data or the ungrouped data is cumbersome to handle and interpret. Therefore, it is slightly difficult to come out with meaningful information for decision making based on raw data. So in statistics, there are several tools available for summarizing and presenting the data in an attractive way, which are easy to read and understand. Some of these are frequency distributions, stem and leaf plots, histograms, frequency, polygons, ogive curves, box plots, bar charts, pie charts, Pareto charts for single variables, and scatter plots for two or more variables. Key statistical concepts and techniques under which this is measures of central tendency. Many a times we feel the need to describe a given data set with one single representative value, usually a middle value. This representative central value of a data set is called as measure of central tendency and can be in the form of mean, median and mode. Here, mean can be understood as the sum of numbers divided by number of values in a data set. Median can be understood as a middle value in an ordered data set, and mode is the most frequently occurring value in a data set. Now, in the following example, as you can see, marks are given as 35, 35, 35, 50, 60, 65 and 70. So in this data set, mode will be 35 because it is occurring 3 times. Median will be 50 because if we arrange this data set in an increasing order, then 50 is the value that is coming in the middle. And mean will be calculated as sum of all these values divided by total number of values, that is 7, which will be equal to 50. For example, a professor of statistics would like to know how his students have fared in business statistics course. So he can calculate mean marks and find out how many students are above average or below average. Similarly, a shoe manufacturing company may be interested in knowing which number shoe shall be manufactured in the factory to earn maximum profit. In this example, the company would prefer mode as a representative value to align its manufacturing resources better. Measures of dispersion. These are also known as measures of variability in the dataset, as these measure distances of dataset values from the central representative value, such as mean, median, or mode. Two most commonly used measure of dispersion are variance and standard deviation. Variance represents average squared deviation of a given values from actual mean in the dataset, and standard deviation is calculated as the under root of this variance. Both of these measures of variability give an idea of shape of frequency distribution. That is, if the values in the dataset are closer to each other, that is mean, then its variance is likely to be very less. And measures of dispersion can be used in number of ways in business decision making. For example, if there is a high variance in the life of a LED bulb, then customers are less likely to buy it. Similarly, if an IPL team owner is buying players for its teams, and if they find that there is a player who has a high batting average but at the same time high standard deviation, the chances are that the team owner is less likely to buy that batsman. Measures of dispersion. There are two more indicators that help us to find out variability issue more deeper, and these two concepts are skewness and kurtosis. Whereas skewness describes how similar a particular frequency distribution of a dataset is to the normal distribution curve, which happens to be the most symmetrical distribution curve. In other words, we try to find out if the left hand side of a distribution curve is similar to the right hand side distribution or not. If these two are mirror images of each other, we call it symmetric, otherwise we call it asymmetric. So skewness represents the asymmetry in the distribution, that how far a particular distribution is from the normal distribution. Whereas kurtosis describes the pickedness of the distribution, which means if the values are more aligned to the mean, we may have more pickedness in the distribution. If the values are far from the mean, then the chances are that we may have flatter sort of distribution. So if it is normal peak, we call it mesocortic. If it is more than normal peak, we call it leptocortic. If it is less than normal peak, we call it platycortic. Probability and probability distribution. This is another statistical concept that is used extensively in business decision making. And probability is something that affects all of us in our day-to-day lives also. Probability can be understood as a chance of happening or not happening something. Its value will always lie between 0 to 1 and is always expressed in decimal or fractions. For example, if somebody says that there are 90% chances of rain tomorrow, then how it's going to affect your planning tomorrow or company's planning tomorrow? Maybe some of you will carry an umbrella with you to the office. A cricket match may be rescheduled for a future date. An open theater commercial event may be relocated to a new venue. And the route of trucks in a fleet company may be rerouted if the prediction is for the heavy rain in the route. In nutshell, probability affects all of us and almost in every aspect of our lives, especially in managerial decision making. It has a great utility as most of the business decisions involve a chance factor in their success or failure. Now, probability distribution. These are theoretical frequency distribution that explain how the outcomes of an event are expected to vary. These distributions are very useful in drawing inferences or making decisions under conditions of uncertainty or risk. Take a case of an investor who is interested to invest in a company's stocks. If the returns that he is going to get from the company stocks is approximately 10%, and say that each share of the company is costing 150 rupees, and also assume that through some past analysis he has been able to find out the possible returns as 0, 10, 15, 25, 50, with their respective probabilities as 20%, 25%, 30%, 15%, and 10% for the mentioned stock. With this data and the given probability distribution, the investor will be able to take a decision to invest or not invest in the company's stock. All he needs to do is compare the required return, that is on an average 10% of 150 will be 15 rupees, with the expected return, which means we are multiplying the return that is going to get with the probable values. So ultimately it will go in the favor of investing in the stocks. So probability distribution can really help us take good decisions in business. Sampling and sampling distribution. Sampling is a way of choosing a part of a population with the purpose of drawing some inferences about population characteristics by studying characteristics of a chosen sample. In simple words, we are trying to study population with the help of a sample, and we are trying to make some inferences about the population by studying the small sample. Now, say for example, through a survey of a small sample, be able to find out who is going to win a political election. Here, normally all the exit polls that are happening, they do survey like this, and they try to study around 5,000 people, and then they generalize the finding of the population that such and such candidate is going to win. So sampling primarily is done to save cost, time, and other scarce resources, and also many a times it may be impractical or impossible to study the entire population to draw some conclusion about population. A sampling distribution, on the other hand, may be understood as a probability distribution of all possible means of various samples drawn from a population, which means we pick up a small sample, all possible samples of a given size from a population, and then if we calculate their means, draw a distribution of all those means, then we're going to get a distribution called sampling distribution. For example, if we wish to know the average mileage of cars of a company, and let's say in our population we only have 4 cars, and we choose a sample of only 2 cars at a time, so we're going to have 6 sample combinations of the cars, that is AB, AC, AD, BC, BD, and CD. Now if you take the mean of mileage of every sample combination and draw their frequency distribution, it will be called as sampling distribution of the means for the population of cars. The next concept in statistics is estimation theory. We estimate the characteristic of a population from a sample in a way that the estimate reflects the true population characteristics to the closest. It has a lot of utility. A marketing manager would estimate the demand for its products in the forthcoming year. A production manager may estimate the raw material requirements. Similarly, an HR manager would like to estimate manpower requirements, and also a finance manager would like to estimate fund requirements for the next financial year using a small data set from the past available data. While estimating, there can be 2 kinds of estimates. One can go with the point estimate, which means we have a single value, single number through which we estimate a population parameter, or we can also have an interval estimate, a range of values within which a population parameter will fall can also be given. Now how these work, we can understand with the help of an example. Say if a manager is making a point estimate about demand, she or he may come out with a single number such as rupees 100 crore, whereas interval estimate of demand forecast will be in a range of, let's say, 75 to 125 crore. It's very obvious that if we give a point estimate, the chances of us being wrong are more, and if we give interval estimate, the chances of our being correct with certain probability are more. So in business, we tend to use interval estimates more. So traditionally, most of the decisions were largely based on hunch, but now with the help of quantitative techniques, that is statistics, we may be using estimation theory to reach approximately to a rational decision. Still more, the other important concept in statistics is hypothesis testing and decision making. In business, we always make one or other claim about possible situations or the outcome of a decision. For example, we may always guess that or may claim that internal recruitment is a more effective source of recruitment. Older employees are less efficient. Females are getting less salary than males. So all these are examples of some of the claims that we can make in an organization. So a hypothesis is nothing but an assumption or the claim that we make about population parameter, which means population parameter means here population mean, standard deviation, or population variance. Since most of the times it is not possible to study whole of the population due to time and resource constraints, so that is why we make an attempt to estimate a population parameter using a sample statistics, which means sample mean, sample standard deviation, or sample variance. To test the validity of a claim made about a population, a sample data is collected and then we find out the difference between hypothesized value and the actual value of the sample mean. Then using probability distribution, in this case sampling distribution, we find out if the difference is significant or not. This significance difference is not merely determined by intuition, but rather it is concluded using statistics. Say for example, a business school claims that an MBA graduate in their campus gets an average salary of rupees 10 lakh with a standard deviation of rupees 10,000. To test this claim, you picked up a sample of 49 passed out students of that college and then calculated their average salary as 9.95 lakh per annum. And by intuition, you may always conclude that the difference between a population claim that was 10 lakh rupees and the sample value that you had collected was 9.95 lakh, and this difference is very small, that is of rupees 5,000 only. So you may treat it as insignificant. However, if we use statistics, we may find it other way around and we may have to reject our null hypothesis. So hypotheses are conventionally formulated as null and alternate. So what exactly is a null hypothesis? So null hypothesis represents a situation of no change, status quo, no impact or no relationship between variables of interest. Whereas an alternate hypothesis is exactly opposite of what is there in null hypothesis. That is, we always say there is a significant change, there is a significant impact of one variable on another, or there is a significant relationship that exists between the variables of interest. This hypothesis testing can be done using several kinds of tests. For example, z-test, t-test, pair t-test, independent sample t-test, chi-square test, f-test. In fact, there are many more which you will study in the coming modules. Analysis of variance, or popularly concept in statistics is known as ANOVA. It's a technique through which we can test the significance of differences among more than two sample means simultaneously. In this, the total variation is decomposed into various components corresponding to the sources of variation. Using this technique, we can draw inferences about whether our samples are drawn from the same population or populations having same means or not. For instance, if an HR manager is trying to find out a satisfaction level, let's say across 3 departments, marketing, finance and HR, and he's getting an average satisfaction score of let's say 7, 6 and 8 for marketing, finance and HR department respectively, then ANOVA will help us compare these 3 mean values simultaneously with following hypothesis, where null hypothesis H0 will mean that all 3 means are equal, and alternate hypothesis, that is HA, would mean that at least one of the means is different from the other. Depending on how many dependent variables, independent variables and extraneous variables we have in our research design, we may choose between variety of ANOVA techniques such as one-way ANOVA, two-way ANOVA, factorial designs, MANOVA, ANOVA, etc. Correlation and regression analysis. In business, there are several situations when one may find that the two events or variables, they appear to be related. For example, motivation at workplace may be related to performance-based incentives. Performance itself may be related to age, gender, educational qualification, work-life balance, etc. In such cases, a manager always feels a need to know more accurately about these relationships through some tangible quantitative measures, and one such tangible quantitative measure in statistics is correlation. Correlation describes the degree and direction of relationship among two or more variables, and its value always lies between -1 to 1, with values nearer to 0 indicating a weak correlation and values closer to 1 indicating strong correlation. Though values of correlation coefficient can also take negative values such as -0.8, but one should be careful to interpret the negative sign as an indicator of direction of relationship only, that is whether it's positive or negative relationship, and should take absolute values ignoring the sign for interpreting the strength of relationship between variables of interest. One of the limitations of correlation is that we can always tell that the two or more variables are highly or weakly and positively or negatively correlated, but we can never say that variable X is influencing variable Y. For this purpose, we have another concept in statistics called regression, in which we can find out what is the impact of variable X on variable Y. Regression, though, can be used for a number of purposes in business situations. First, it can check if any relationship actually exists between a dependent variable and a set of independent variables. Second, it can also be used to find out the relative importance of various independent variables in impacting the dependent variable. Still further, regression can also be used for predicting values of dependent variable Y for a given value of independent variable X. And statistically, a simple regression model can be expressed as below, where Y is equal to A plus BX plus U, and Y where is dependent variable, X is independent variable, A is intercept, that is value of Y when X is 0, and B is the regression coefficient or the parameter which we try to estimate through a model. Other important concept in statistics is forecasting using time series analysis. Forecasting is all about predicting future, be it predicting manpower requirements, raw material requirements, demand for products, fund requirements, or predicting some other kind of requirements in the organization. So forecasting is needed for all kinds of business decision making in the organizations. In fact, virtually every functional area of the business, including production, sales, HR, transportation, distribution, or inventory, maintain time series data which can be utilized for coming out with some forecast which can be utilized for taking business decisions. For prediction, time series forecasting is one of the popular technique that makes prediction using data gathered on a given characteristics over a period of time. For instance, sales data of past 10 or more years can be used to predict the sales for forthcoming year. Time series forecasting techniques takes into account the changes happening in characteristics such as sales by examining their patterns, trends, cycles, etc. There are various methods available for time series forecasting such as naive method, moving average method, exponential smoothing, regression trend analysis, and decomposition of possible time series factors. Decision theory. The decision theory deals with those mathematical and statistical approaches that enable a decision maker to evaluate and judge the best available alternative opportunity. Decisions are generally made under three kinds of conditions or situations, that is decision making under certainty, number 2 decision making under uncertainty, number 3 decision making under risk. Most of the decision problems will have three important variables, namely decision alternative, which means the options available to a decision maker out of which he or she has to make a choice. Number 2, states of nature, That is the situation or the conditions that arise after the decision has been made and over which the decision has no control. And number three is payoff, that is the gains or the losses that decision maker will reap by exercising various decision alternatives. The decision theory can be understood with the help of this example, where the three aspects, that is decision alternatives, states of nature and payoffs, are shown in the table below, where we are trying to find out what is the yearly return of an investment of rupees 10 million rupees. In this case, the states of economy, three states of economy, are whether the economy is stagnant or it's in the slow growth mode or it's in the fast growth mode. And investment alternatives to a manager are whether to invest in stocks or in bonds or in mix of stocks and bonds. And based on these three states of economy and three alternatives, we have 9 kinds of possible payoffs coming our way, which means either we'll gain or we'll lose. So the expected returns from these 9 combinations are, if, as we can see in the first cell, if we choose stocks in stagnant economy, the chances are that we're going to have 10% loss on our investment. Similarly, if we choose, let's say, exactly middle of the road, which means we go for slow growth and we choose bonds, so we're going to have around 7% return on our investment. And lastly, if we choose fast growth and we go for the mix of it, which means we invest in stock and bonds, so we're going to have around 14% return on our investment. In decision under certainty, the most elementary of the decision making situation, the states of nature are known with certainty in advance, and decision maker has only one thing to do, that he has to see that in which state payoff metrics one can reap maximum benefit. So the outcomes are certain and the alternatives are known, so one can choose that alternative where the benefits is maximum. Decision making uncertainty can be of two types, where the uncertainty is full or where the uncertainty is partial. That means decision making is happening under risk. So uncertainty happens when the occurrence of the states of nature and the probability of its occurrence is not known, and in such scenario a manager may take any decision based on what is his psychological orientation, his risk taking capacity. So largely on hunch and experience people take this kind of decision, whereas decision under risk, which means partial uncertainty, managers may have tentative or the probabilities assigned to the outcomes and their respective payoffs. So there are several approaches to solve problems of uncertainty, like max criterion, max minimum criterion, Horwick criterion, and minimax criterion. So students, let's now summarize what we have learned in this module. See, this module has provided the basic understanding of quantitative techniques. Quantitative techniques can be understood as a collection of mathematical and statistical tools that are used to provide powerful means of analysis using quantitative data for effective decision making in business. These tools help business in taking effective business decisions and hence result in optimum utilization of resources. Decision making is a systematic process involving several steps, such as identifying the right problem or the issue, identifying decision criteria, allocating weights to decision criteria, generating alternatives, evaluating and choosing an alternative, implementing the decision alternative, and finally evaluating if the decision alternative was effective or not. So decision can be structured and programmed, or they can be unstructured and non-programmed. Broadly, there are two types of quantitative techniques. One, mathematical quantitative techniques, and second, statistical quantitative techniques. While the mathematical quantitative techniques include wide range of tools such as algebra, set theory, permutation and combinations, matrix algebra, determinants, differentiation, integration, differential equations, etc., and several mathematical programming techniques such as linear programming, assignment and transportation models, dynamic programming, inventory control, game theory, queuing theory, replacement models, simulations, decision theories, network programming, sequencing, quadratic programming, branch and bound techniques, etc. And these techniques use largely mathematical principles to solve business problems. But this part is beyond the course of this current paper. The second part, which is statistical quantitative techniques, which forms the main content of this paper, uh, it includes statistical concepts and tools such as data classification, tabulation and presentation, measures of central tendency, measures of dispersion, probability and probability distributions, sampling and sampling distributions, estimation theory, hypothesis testing and decision making, analysis of variance, correlation and regression analysis, forecasting using time series analysis, and decision theory, etc. for effective decision making. The current course covers statistical quantitative techniques, as I've already said, and it excludes mathematical quantitative techniques, as that is beyond the scope of this course. Thank you so much.